Hi, in this video we are going to discuss a summary of some strategies used in the K-3 curriculum to help students understand addition. So we will be making some references to the set model and the measurement model, because those are both ways to introduce the operation to students in the K-3 curriculum. And we'll also talk about some useful facts and strategies that can help students become proficient in addition. So let's go to the document camera and look at some examples here. Maybe I'll pop up here in the lower right-hand corner. Yay. Okay. So the concept of addition can be explained or introduced with models. So let's just do a simple example. We'll be doing 4 plus 7. So if we're talking about the set model, this is a way to visualize the set model for 4. That's a way to visualize for 3. And we combine everything into 7 things. Okay. Now, there are a couple of ways to understand this operation in the measurement model. All right, so one of those ways is to think about a number line and you're kind of stepping off. So we're doing 4 plus 3, so that's 1, 2, 3, 4. So we start at 4 and we go 1, 2, 3 steps, and that gets us to 7. Okay, so we could also visualize this as like lengths of bars or sticks, or however you want to think about it. Okay, so here's your four lengths, and your 3 lengths, and then you can see together you have a total of 7 of these. Okay, so the concept of addition is actually introduced in kindergarten, and there's some development and practice happening through 1st and 2nd grade, and it's typically in 2nd and 3rd grade that we start to learn the algorithm, the standard pencil and paper algorithm for addition. And that development and practice phase that we talked about, that's 1st grade into 2nd grade, we're talking about a combination of mental math, that students would be doing some worksheets, some short word problems that are just like a sentence or two to get them to do the operations. And the goal is to get down addition facts. So in other words, they need to learn these things here. So certainly the students would need to learn the meaning of addition. And they would need to know sums within 20. So in other words, basically from 0 plus 0 up to 10 plus 10. They would eventually need to have that stuff basically memorized by the time they're getting into 2nd grade and starting to learn the algorithm. Okay, so let's talk about some useful facts and strategies to help people learn addition. So, we'll call these teaching / thinking strategies. Okay, so the first one is adding on. In other words, stuff like +1 and +2. Second thing, what happens when we're adding 0? Okay, so this is pretty easy once it's taught. So the adding on technique builds on what the students know when they're counting. And this is easy because adding 0 does nothing. Okay, that's not really an addition fact, that's just sort of a property of 0. Zero is the additive identity. Another important teaching and thinking strategy is the any order property of addition. Okay, you have commutativity, and you have associativity. Okay, so in commutativity, we can do things like switch the order. Okay, if we had 2 plus 9, that's the same as 9 plus 2. And I would argue this is actually an easier problem because now we can do the adding on, we can do the counting on. If you're doing a counting on strategy here, this one's going to take a while, and the student might lose track in the middle of the problem. But if they're using a counting on strategy, going 9, 10, 11, okay, they're done. They got it right there. The associativity property. This is handy because let's say we had, let's go, I don't know, 4 plus 2 plus 7. I can group it that way. Let's make it, go ahead and make it 4 plus 2 plus 8. I can group it that way, or I can group it this other way. And this is the easier way to do that problem. Tell you what, let me get out of the way here. This is easier because now you've made a 10 here. 2 plus 8 gives you 10, 4 plus 10 is 14. Okay, so that's a simpler way to do that addition. Okay, so knowing what happens when you add 10 is a useful teaching and thinking strategy. This goes back to the place value material that we discussed earlier. Knowing your tens combinations is very important, so don't forget you have 9 plus 1, 8 plus 2, 7 plus 3, 6 plus 4, 5 plus 5. Okay, that's essentially what I was talking about right here. The reason I said this is easier is because, okay, I saw we have a 2 and an 8 in the mix, and the associative property of addition lets me add the 2 plus the 8 first to make a 10. And then I do 4 plus 10, which gives me 14. So whenever you can incorporate a tens combination, it usually makes the problem easier. Using doubles is a convenient strategy here. So if I'm doing something like 7 plus 8, I could visualize it as 7 plus 7 plus 1. So I double 7 to get 14 and then add 1 to get 15. Okay, so using doubles. And then the property of compensation. Now this is important for doing mental math. forget what number I was on. This is strategy number 7 here. Okay, so compensation for dealing with mental math. This is especially nice if you're dealing with 9s, right? So like 9 plus 7. If I wanted to do that mentally, I might take a 1 from the 7. So 9 plus 7, if I take away 1 there and give it to the 9, I have 10 plus 6, and now it's a adding 10 problem for 16. All right, now I know that you guys have your addition facts memorized. So to help you understand why the compensation tool is useful, we're going to look at some 2-digit problems, okay? So we're going to be doing some mental math, and the stuff we're doing is not necessarily stuff you would show students in the K3 curriculum, but it's to help us understand why these are useful. So let's do some mental math examples. Okay, so, let's do 38 plus 42. Okay, 38 plus 42. Now, I could sit down and write this out with the standard pencil and paper algorithm, but we can do this very easily in our heads, all right? We're thinking of tens combinations and compensation to make tens combinations happen. So what I'm going to do is I'm going to take 2 away from here. So this becomes 40 plus 40. So we got a total of 80. Okay, so 38 plus 42 is 80. All right, now I'm writing this stuff out now so I can invite you into my thought process. But when I see this 8 here and that 2 there, I notice, okay, there's a 10 combination. So I'll do compensation to make 10. And you can do this in lots of different ways. Let's say I had something like, I don't know, 71 plus 29. Okay, there's a 10 combination right there. Take that 9 over here. So you're getting 80 plus 20. So that comes out to an even 100. Okay, and it doesn't have to necessarily be a 10. It can be 100, it can be 1,000. Anything that can get you to an even power of 10 is really what's important. So let's do something like, oh, I don't know, 436 plus, I don't know, 97. Okay, that's very close to 100. Take 3 away from this. So you got 433 plus 100, 533. It's actually much easier than the standard pencil and paper algorithm would be, because you'd have to do 2 carryings if you did the standard pencil and paper algorithm. Okay, let's look at something like this. I don't know, 36 plus 35. We're going to use our knowledge of doubles here. Okay, it's the same thing as 35 plus 35 plus 1. And of course, we know double 35, you get 70, so you get 71. Okay, so anytime you're kind of close to a multiple of 10 or a multiple of 100 or anything like that, think about the compensation strategy to make the problem easier. And this is stuff that we are eventually going to want to do exclusively in our head. Okay, we want to have this stuff so ingrained that we can do it without thinking. But of course, I'm writing it out here to demonstrate what I'm thinking when I do these mental math problems.